Question 25. Rectangle ABCD is the horizontal base of a triangular prism ABCDEF. AE is equal to BE. EM is vertically above M, which is the midpoint of AB. We're told that AB is 16 centimeters, AE is 17 centimeters, and BC is 30 centimeters. And we need to show that EM is 15 centimeters. Okay, so first of all, I'm gonna mark in all of the lengths that I know. So I know that AE is 17 centimeters, so that's going to be this distance here. I'll mark it as 17. And then I know that AB is 16 centimeters. So this here, all the way across is 16. Because M is the midpoint, that means that's going to be 8, and that's going to be 8. And I'm also told that BC is equal to 30 centimeters. So this length here is going to be 30. Okay, so to show that EM is 15 centimeters, I need to recognize that EMA is a right angle triangle. Now I know AM is 8, and I know that EA is 17, so I should be able to work out what EM is. So I'm just going to draw the right angle triangle here separately. So we're going to have this triangle here, a right angle, that's 8, that's 17. I'll label the vertices as E, A, and M. Okay, so 17 and 8, using Pythagoras, I should know that I can work out EM. Sorry, I can work out, EM. And that's going to be equal to 17 squared take away 8 squared square rooted. Using my calculator, I can do 17 squared take away 8 squared square rooted, and that gives me 15. So we could say therefore EM is equal to 15 centimeters. Okay, part B says work out the angle ECM. So we're trying to work out the angle made if I drew a line that goes from E through to C. So again, what I'm going to do is I'm going to just sketch the triangle ECM. So I'll do that over here. So we've got E to M to C. Okay, so we've got a triangle that looks like this. This is going to be vertex M, this is going to be vertex E, and this here is going to be C. Now, of those three lengths, I know that EM is going to be 15 centimeters because we've already worked that out. Okay, I don't know the length MC and I don't know the length EC, so at the moment I can't work out the angle ECM, which I should label here as that there. And we're just going to call that theta. Okay, so I need to know two lengths so that I can use trigonometry to work out theta, because this is a right angle triangle. Right, so what I can do though is I can work out this length MC. So let's just draw that in. And that's going to be from there to there. Well, I can work that out using this right angle triangle, which is CBM. So I'm just going to draw that triangle. I'll draw that over here. Let's have another triangle that's going to be I'll try that again. So we'll have CBM. Okay, so my right angle is going to be at B here, and then I've got a vertex here at C and a vertex here at M. And of these, well, I know that BM is 8, and I know that BC is 30, and CM is something I can now work out using Pythagoras, and that's going to be the same as the CM here, so the length is going to be the same as that there. So using my calculator again, I can say, let's write this down. So I'm going to start by working out CM, and CM is going to be equal to 8 squared plus 30 squared square rooted. Okay, so this time we're trying to find the hypotenuse. So using my calculator again, square root of 8 squared plus 30 squared, and that gives me 2 root 241. So CM is equal to 2 root 241, and we'll just leave it like that for the time being. Okay, so I can now label this in over here. I know that this length here is going to be 2 root 241. Okay, so now I know the opposite side and I know the adjacent side. So to work out what this angle here is, I'm going to use tan, and I know that I'll write it down. I know that tan theta is going to be equal to the opposite side divided by the adjacent side. So that's going to be 15 divided by 2 root 241. Okay, so I can work out theta by doing the inverse tan of this here. So using my calculator, I can do, so we want to do the inverse tan of 15 divided by, and it's the answer that's already in my calculator. I'll type it in again though, 2 root 241. And that gives me an angle of 25.8 degrees. So this angle here is 25.8 degrees. So that means that the angle ECM is going to be 25.8 degrees. Question 26. Here is an L shape. We're told that all dimensions are in centimeters. This length here is 9 centimeters and it's fixed at 9 centimeters. This length here is fixed as 10 centimeters. We've got an unknown length of x centimeters here, and we've got an unknown length of 3x plus 1 centimeters over here. We're told that the area of the L shape is 65 centimeters squared, and we need to work out the value of this unknown x. So to start us off on this question, we're going to come up with an expression for the area of the shape. And then we're going to use that expression to form an equation using the knowledge that the actual area of the shape is 65 centimeters squared. So to form this expression, we're going to start by splitting the shape into two. So I'm going to draw a vertical line down here. I can now come up with an expression for the area of this rectangle, which is going to be 9 times x, which is 9x. And I need to come up with an expression for the area of this rectangle. I know that this length here is 10 centimeters. I know that this length here is x. So I can write down this length here, which is going to be 10 take away x. So that means that the area of this rectangle here is going to be given by this length, 10 take away x, multiplied by this length, which is 3x plus 1. So to form an equation then, I need to do the total of the area of the shape, which is given by the sum of these expressions, and I need to make it equal to 65 centimeters squared. So I've got 10 take away x multiplied by 3x plus 1 plus 9x is equal to 65. So my expression is equal to 65, and that turns it into an equation. I'm now going to expand and simplify the left hand side. So I've got 10 times 3x, which is 30x, 10 times 1, which is 10, negative x times 3x, which is negative 3x squared, and negative x times 1, which is take x. And I've got this plus 9x over here, and that's going to be equal to 65. I can then simplify this, so I've got a negative 3x squared, 30x take away x plus 9x is plus 38x, and I've got a plus 10 equals 65. So I've spotted now that this is a quadratic equation, so I'm going to make it equal to 0. So that's going to give me negative 3x squared, and I'm going to subtract 65 from both sides, plus 38x. And if I subtract 65, that's going to be take 55, and this right hand side is going to become 0. Now this next step's unnecessary, but I'm going to do it anyway. I'm going to multiply everything by -1 because I want this to be positive. It's just neater to work with when the coefficient of x squared is positive. So that's going to be -1 times negative 3x squared, which is positive 3x squared. If I multiply this by -1, I get take 38x. I'll multiply this by -1 and it becomes plus 55. And then I can multiply this by -1 and I get 0. So I've spotted now that I need to use the quadratic formula to solve this. So I'm going to write down the quadratic formula over here. X is equal to negative b plus or minus the square root of b squared take 4ac all over 2a. So I'm going to now write down the values of a, b, c and the discriminant b squared take away 4ac. So a is equal to 3, b is equal to negative 38, c is equal to 55, and then b squared take away 4ac is equal to, and I'll use my calculator for this, and I've got negative 38 squared. Just notice that I put that in brackets because I want my calculator to understand I'm squaring a negative 38. So that's the b squared part, take away 4 times a, which is 3, times c, which is 55. And I get 784. Okay. I can now substitute this into this equation here. So I've got x is equal to negative b, which is 38. And I'll do it once with a plus. So plus the square root of 784 divided by 2a, which is 2 times 3, which is 6. I then got the same equation again, but with a take away. So take away the square root of 784 divided by 6. So using my calculator now, I can work out that 38 plus square root of 784 divided by 6 is equal to 11. And then I can do the same thing again, but with a subtract. And that gives me x is equal to 5/3, and I'm going to write that to decimal. So 1.67. We've got x is equal to 1.67. Now, for our answer, we need to decide which of these is going to be valid. It may be that they're both valid. But if you ever think about this, if x was equal to 11 centimeters and this is equal to 10 centimeters, that's not quite going to work for this shape. So we need to disregard this x equals 11 because it doesn't look like that's going to be possible. So our actual answer is going to be this one here, which is 1.67 centimeters. That does work. So x is equal to 1.67 centimeters. There we go. Question 27. We need to prove that x squared plus x plus 1 is always positive. Now there's a few ways we can go about doing this proof. What I'm going to do is I'm going to prove it by completing the square. So I'm going to complete the square on this expression first of all. So in order to do that, I know that I'm going to have x plus a half of the coefficient of x there. Well, the coefficient of x is 1, so this is just going to be a half squared. So x plus a half squared would be x squared plus x plus a quarter. So I need to take that quarter away. So this here is now the same as x squared plus x. I'm now going to add 1 to that to make it the same as this expression. So I've got x plus a half squared, take away a quarter plus 1. I can simplify that because that's going to be x plus a half squared, take away a quarter plus 1 is the same as plus 3/4. Now I can see that this part of it here is always going to be positive because when I square something that's real, I get something that's going to be positive. I've now got a positive number and I'm going to add 3/4 to it. So I'm going to add on another positive number. So that means it's definitely going to be positive. So I've kind of proved that it's always positive, but I now need to write a couple of statements that show that this is always going to be true. So I know that x plus a half squared has to be greater than or equal to 0. It always has to be positive. I can also see that that 3/4, well, that's definitely greater than 0. So I've got something that's greater than or equal to 0 and something that's greater than 0, and I add those together, I'm going to get something that's positive. So I could say always positive. Okay, thanks very much for joining me. I'll see you next time.